In 2.3, we're going to be looking at finding inverse functions. So I want to give you some steps and processes, and I'm going to repeat this repeatedly as we work examples. So not a super long lesson because it's only about inverse functions, but I want to make sure you understand the steps and what kind of is going on in the background as you do these steps. So how to create an inverse function. Here's our steps. We're going to replace f of x with y. Exchange our x's and y's. Solve for the new y, and then replace y with f prime of f to the negative 1 of x. So this means f inverse, you place a small negative 1 between the f and the x. And so if in the instructions they just tell you to find f inverse, that's what that notation means. Similar to section 1 in this unit, where the notation was your instructions. So also notice in this, we're exchanging x's and y's. So let me just make a comment of what's being done behind the scenes. If you're exchanging x and y, remember x was your domain and y was your range? That means in general, if you're exchanging the x and y values, the domain of one becomes the range of the other, and vice versa, because of this step right here. And so some of the problems you encounter, it might even talk about what's the new domain or what's the new range. Well, you have to go back to that step 2, the fact where you're exchanging the x's and the y's. So I want to work quite a few problems with you and just kind of walk us through the steps. So it says find the inverse of the function. So it might just flat out tell you find the inverse. So 1, replace f of x with y. So I'm going to say y equals 2 over x minus 3 plus 4. Exchange x and y. So I'm going to say x equals 2 over y minus 3. So I've switched my x's and y's and I've left everything else the same. Step 3, solve for the new y. So I want to get this y by itself. So I'm going to subtract 4 from both sides. Then I am going to have to multiply by y minus 3 to get that out of my denominator. So that gives me y minus 3 times x minus 4 equal to 2. Divide by x minus 4. My goal is getting that y by itself. I'm just moving things from side to side by doing opposite operation. So that gives me y minus 3 equal to 2 over x minus 4. And then add 3 to move it over. So I get y equal to 2 over x minus 4 plus 3. And then step 4, replace y with f inverse. So I'd say f inverse of x is equal to 2 over x minus 4. Excuse me, got off screen there. Plus 3. You'll notice things started moving around. Addition turned to subtraction, multiplication turned to division, etc., etc. So you just want to go slow, take each small step. Now, if you struggle with solving for x, we need to go back to that. You need to contact me. I'll give you some resources. You need to go back to how to solve for x, because we're just applying it in the case of this inverses. Excuse me. Now let's do it in another one. So all it says is j of x is equal to the cube root of x plus 14. They want us to find j inverse. See, no words, just notation. That's your instruction. So first thing, I'm going to replace f of x, or in our case, j of x, with y. So I'm going to say y equals the cube root of x plus 14. Exchange x and y. So I'm going to write an x here and a y here. I'm bringing everything else down. I switched over to that pencil there because I want you to see the difference on how I went from this step to this step. Now I'm going to solve for the new y. So I'm going to get this y by itself. So the first thing I have to do is I have to cube both sides to get rid of that cube root. And then subtract 14. I expect to see steps and processes as you're working this, not to just, if it's multiple choice, to be guessing at an answer. I want to see these steps on how you got to that inverse. Don't try to stare at it for a while and look for patterns. Just follow your steps. You know how to solve for x. So the only thing that we've done differently here is exchanging that x and y. And then lastly, just kind of a piddly-wink step here, replace y with f inverse. And so we could say j inverse of x is equal to x cubed minus 14. So let's do another example with that. It says, part 2 of this is how to test if two functions are inverses. So once we get the steps on how to find the inverses, now let's see if we can prove that they are inverses. And this goes back to section 1. So if you haven't done section 1 homework, go back, complete the homework before you start in on this one. So here's our process. Determine whether f composed with g, see if that gives you x. Then compose g with f of x and see if that gives you x. So if you take your f function, compose it with its inverse, or what we assume is the inverse, if you compose them two together using template and plug-in like we did in section 1, and you get x, and you do the reverse plug-in, template, plug-in, and get x, both of those are true, I could say those are inverses. So it says if both statements are true, then f and g are inverses of each other. If one of them is false, they're not inverses. So in this case, we're not creating the inverse, we're trying to prove that it's an inverse. So it says, if f is equal to this and g is equal to this, is g equal to f inverse? Meaning, is this the inverse function of this one? So we're going to have to compose them together. We're going to have to do f composed with g, and we're going to have to do g composed with f, and figure out if we can do this. Again, going back to what we did in 2.1. So remember, the first letter is your template. So I'm going to write my f function, 1 over something plus 2, and plug my g into that something. My g is this, so it would be 1 over x minus 2. Now I'm going to clean that up. You can see negative 2 and positive 2 cancel, and I get 1 over x here. Now going back to how you divide fractions, this says 1 divided by 1 over x. Remember, to divide fractions, you keep it, change it, flip it. So you keep the first, change it to multiplication, flip the second, and that gives me x over 1, or just x. So f composed with g gave me x. If we can get this one to give us x, then we know these two are inverses of each other. So again, g is your template, f is what you're plugging in. And so I'm going to say g, so there's my g, it's 1 over something minus 2. What I'm plugging in is my f function, so that's 1 over x plus 2. Again, this is 1 divided by this, so I'm going to keep it, change it, flip it. So keep the first, change it to multiplication, flip the second, minus 2. And you can see over here, that just gives me x plus 2, minus 2 from way up here. Those cancel, and I get just x. So since when I composed them this way I got x, I composed them this way I got x, then g is f inverses. Let's do it with this other one. It says if f of x is equal to x cubed, the cube function, and g of x is equal to 1/3 x, is g the inverse of this? So I'm going to compose them together. Say f composed with g. I'm going to say g composed with f. I like to use different colors because it kind of helps me to see where I'm plugging in. Okay, so f is my template, so I'm going to have something cubed, and that something is going to be my g, so 1/3 x. So when I cube this, this actually gives me 1/9 x cubed, and I really can't do anything with that. So already, I'm thinking these are not inverses because that is not a singular x like we got up here. Let me just go ahead and work out this one, make sure, see what I can see from it. Okay, so g, so that's going to be 1/3 something, 1/3 x. That something is going to be x cubed that I'll plug in. And that gives me 1/3 x cubed. So this is absolutely not inverse because that's not equal to x, that's not equal to x. So we thought maybe having a 3 in there might make it an inverse, but it didn't work out for us.